So the big lesson that we've been coming to learn over the last year or two is a difference between imperative and declarative styles of programming, and the times that we get the benefit. We found that most of the time we get benefit from at least thinking about how something can be declarative. And I jumped straight into jargon, so I use a lot of examples to describe what the difference is for me, because they're sort of the same. It's a terrible way to start the presentation. They're totally different. But an example of imperative style of programming is if you're making a user interface as a JavaScript programmer or any kind of user interface designer, is to think of your code as adding 2 checkboxes to the UI. So you might have a for loop or something that loops from 1 to 2, adds the checkboxes. Imperative style, you are adding checkboxes to a UI. In a declarative style, you just decide that there ought to be 2 checkboxes. Sounds great, right? For a little bit of further example, in an imperative style for a whole to-do app, might be you have a title, it says to-dos, add 2 checkboxes to the UI, and then when the user checks a checkbox, at that point see if the other checkboxes are checked. Oh, you guys super can't see this. If you get your phones, you can see it on your phone too. And if they are all checked, then add all complete to the title. Right? So you can say on your phones if you want, if you ever write code like this. And I can project the answers, and everyone's so involved. And Joel's writing down the bug report about the layout of the screen. This is like the common way to program. But we found at Pear Deck, and whatever we found, like the whole JavaScript community and everybody else found, that you can switch to declarative code. The same example in declarative code might be, first of all, there are 2 checkboxes already. I declare it to be so. And when they're both checked, the title ought to be to have all complete in it. When they're not, it should just be to-dos. Right? So I hope the difference is starting to be clear. In the declarative type of programming, I'm not saying what should happen, like add 2 checkboxes and then add stuff to the title. I'm saying, like, this is how the universe ought to be. It's so declarative. Oh, look, you all already write code like this. So you know exactly what I'm talking about. I promise not to talk about UI for the whole time, but I do want to talk, when we're just talking about the UI, about how much better declarative is when you can pull it off. So the declarative code is simpler, and I think that makes it better for a bunch of reasons that I'll go into right now. But first, I'll just prove to you that it's simpler. First of all, the imperative code here, this is back to our first example. You don't need to reread it if you don't want. Imperative is more complicated in 2 important ways. One is this is more lines of code, right? You have to set things up, and then you have to add 2 checkboxes, and then you have to change the title. But it's also really important to acknowledge that this code is more complicated in terms of time scale. This code, especially, like, let's just look at step 3. We have, step 3 is when the user checks a checkbox, then at that point, see if they're all checked. And then after that, if they were all checked, do this third operation, which as your code is doing other things at the same time, that like time scale interacts and gets super complex. In the declarative example, this second thing that controls the title doesn't have any time associated with it, except the current time. If the checkboxes are currently checked, that's what the title is. There's no like, do this, then this, then this. Making sense? Project your response. We spent a lot of time in the program. I like to use the buttons. So yeah, declarative is simpler. And another way of saying that is that in declarative programming, you just have to describe the states that you want your program to get to. Like all checked and not all checked are the 2 important states in this program. But in the imperative style, you have to write every line between all the states. And there's no like skip the obvious ones. You have to specify every single little command to get through every single little state or you'll get a bug in your program. For example, Let this happen automatically after I'm done talking. the imperative code here, this is a simple app, right? 3 lines. But it kind of has a bug in it. I don't know if anyone feels like they see the bug. But the weird thing here is that the buggy thing is that we've described what happens when the user checks the checkboxes, right? And we have this time complexity I was talking about where they check both checkboxes, so now we add all complete to the title. But if the user at this point unchecks one of the checkboxes, we haven't said like how to go back to uncomplete, right? And that's an easy thing to miss your first review. You don't think like, what if there was an error in the middle of something? And even in this code, I don't know how many of you found or noticed that it was sort of incomplete, but it does have this unspecified behavior where the declarative program, if a user unchecks a checkbox here, the second bullet here clearly says the title should just be to-dos. And it will sort of automatically go back. You don't have to remember that this crazy thing could happen where somebody falsely lied at their to-do list just to make themselves feel better about themselves. Not that I would ever do that. The other thing about the time ordering is like these 2 lines of code can be reversed. This program would still work if these commands were in totally different order. But our imperative program, they have to be in just the right order. And having to make things in the right order is complicated and annoying. All of our code reviews are like, this works, but it's complicated and annoying. You'd be surprised. This is more productive because everything's easier. It's obvious. You still feel free to disagree with me, even though I'm really trying to use it. Oh, we should let them explain our responses. A third way that the imperative adds complexity to every part of your organization is that when you want to change imperative, because it has this time thing, you have to find just the right place to add behavior and do a complicated, annoying-looking program there. So at Pear Deck, everything that you submit or check, you want a little saving spinner, and then every internet request you make might fail, right? So there's always errors. So even a simple thing like 2 checkboxes and a complete thing will have saving indicators and error indicators, and you have to add, okay, like they checked both checkboxes, but one request is still out for saving. So when that saving request is done, then check to see if they're all successfully saved. Unless the user like clicked the other checkbox while the saving was happening, and then I have to check to see if when that returns, if any other requests are in flight, and you very quickly have this, like you can't get a hold on how to just say if the 2 checkboxes are checked or errorful. Oh, we got pictures. Can I just click this and it goes up? I would definitely buy this for my school. In declarative programming, when I want to add behavior like saving an error, I can just list more states, right? Like if some are saving, why don't you put a saving indicator? And if some have error, put an error indicator. And if it goes from saving to error, then back to saving, back to all complete, as a programmer, I don't have to program that. That's like handled because I've described all these different states. All these edge cases are handled automatically. I'm not saying there's never any bugs. Like this also has a bug in it. You see if you find it. If you use static types, then it will show you the bug immediately. But if you work with JavaScript, it won't. Can anyone? Let's see. How do I overlay that here? Oh, there's this overlay. You could try to circle the bug. So yeah, I know that I talk fast and faster when I'm nervous in front of a bunch of people. Any questions or comments or corrections so far? We're about to get to what I actually said we were going to talk about. Yeah?
There is still some internal hooking functions that keep track of, like, is everything saved? Is there everything in flight?
Are you declaring that there are, I didn't mean to make a pun. You're saying there are, or you're asking me if there are?
I'm assuming there are.
Yeah, so there's one problem with all of this, and it's that declaring stuff doesn't do anything. Reality has this like annoying imperative interface where your computer actually is in a current state. You can't just say like there's a million and a half checkboxes and have it be true. So that's what I'm going to talk about right now. It is important to realize that declaring stuff is nice, it sounds great, but you can't just say that your user is happy and have happy users. And you can't just say that you have a user interface and have it be like that. Because, like, computers do things one step at a time, and at some point you need to do things one step at a time. So that's the brilliant realization that I think React and Angular have brought to the wider web community recently, and then smart people from like 1960 did before. We all thought we were cool. I call that statey part the reconciler. You need a program that takes your declaration and looks at the current state of reality, like, oh, so annoying, and knows all the annoying steps it needs to do to make reality look like your declaration. And I call that a reconciler.
You want to know what we called it in the 70s?
Yeah.
We called it the program. The other things were just cars.
Interesting. What language do you use to write the program? Whatever language. That's just how you did everything.
There were three of them.
When did we start falling? When did we start falling into the abyss of like everything's a program?
Yeah. Well, so then you had these sort of languages that weren't languages, right? Like HTML, they're just parameters to the program.
Oh my god. This is awesome. I think we should switch speakers. I would love to hear more about the historical context. I apologize for being so arrogant as to, I've been doing this for over 6 months at this point, so I do know some things, but if you have anything to add, please do.
It's the only thing I have to add is the historical.
Cool. Well, thanks again. So we have the imperative, which actually works on computers. And then the declarative part is what we wish we could do, right? But this would never work. You can't just say things. So here's a way to refactor the imperative. Not I'm trying to make any points yet. This is just the same thing. The imperative program. When the user checks the checkbox, we have this time element. Recalculate the state you want. This is still imperative. You should do recalculating. And then at that point, reconcile the view. Reconciling is the part that we can sort of factor out. And the beautiful part here is it doesn't matter. I should ask you first. In some ways it matters. In some ways it doesn't matter how you implement the reconciler. But the beautiful part is that somebody else can implement the reconciler. So one way to write the reconciler would be to say, if the title's not what it ought to be, delete the whole element and replace it with the right one, right? And that's how Angular works. Another implementation of the reconciler would be, if the title's not what it should be, find the diff between the current text and the text you want and apply the diff, like either adding characters or whatever. And that's closer to how React works, although they basically work the same. Another reconciler would be like, oh, you want a new state? Let me redo everything. I'll just redraw the entire screen. And that's how video games work. Obviously, I'm simplifying everything. This is what Angular looks like. It looks like HTML, but it's not. It's a template for Angular. And it will make your tag look just like you want. This is what React looks like. It looks kind of like HTML, kind of like JavaScript, and we can talk about that for the next 3 hours. These are all things that do this for specifically HTML and the DOM in browsers. And CSS works like this already. Am I like way over time? Can somebody give me attention? 7:50. I'll go faster. Sorry, everyone. Yes, that's what I wanted for you to talk faster.
I have a quick question.
Yeah.
Is the reconcilers a word that's used for this more broadly, or just what you call it?
You know, as I was walking over here, I was like, I should look what other people call this.
Like when we've talked about that term within our work and stuff, we usually refer to it as like convergence as the verb anyway. I don't know how to noun that very well.
Converger?
Converger. I think one distinction in my mind anyway is reconcile implies that it's one step, whereas convergence implies it might be actually many steps.
Okay.
I don't know how important that distinction is, but in convergence it frequently is many steps, and in some of this it might actually be many steps as well.
Yeah, it
and
definitely.
you can think about reconciliation the same way, but I feel like it does imply more of a like whole world solution. We were in one state, now we're done. Instead of convergence, like we're one step closer, we have maybe 5 to 10 more steps to go, but we're closer.
Right.
So
interesting. For this side of the room, Wes was saying reconciler kind of makes it feel like it happens all at once, but what actually might happen is like eventually the reality will reflect your declaration. So maybe converger is a better word.
It's a worse word. It's hard to say, but it might be more.
I bet somebody smart in 1965 was like, and it will be called.
It allowed me to be more pedantic in this conversation.
I can ask a quick question about how.
So is there like a limit to what you can declare? I mean, what you declare leaves you with multiple states in which that satisfies all the constraints?
Right. So that's like the program I had a bug where if some checkboxes were in error and some were saving still, there was a non-determinate which state you should be in. And so if you have a strong enough language or another way of saying that is a small enough problem, then you could sort of prove that your declaration doesn't have holes like that in it. In our case, I think Angular would just like pick the top one. At Pear Deck, we use Angular for our DOM reconciliation and Kubernetes for our server reconciliation and Docker for our software configuration reconciliation.
Converger.
And the declaring endless loops, this is so great because the declarations in general don't have like a sense of time. And so your reconciler implementation might have an endless loop, but your declarations happen kind of all at once. And so there's no like loops. There's nothing changing in a declaration. You just say like, in this case, this is what ought to be. Your reconciler can definitely have endless loops. Don't open some pages on Pear Deck. I'm going to move on, and it seems like there's a lot of great questions. You can leave them here, and we can talk afterwards more. And of course, you can talk to other people. But it's not just for UI. Rainbow. Sparkles. For problems like, this is the software that ought to be installed, we could use Puppet or Vagrant or Docker, or there's lots of other things. I hope Puppet is right. So where our last reconciler was like, what checkboxes should be on the screen? That's like a UI reconciler. But I couldn't say like, and it should have Microsoft Word. The reconciler would crash, probably. But Docker is a reconciler that actually is like, okay, now Microsoft Word is installed. And then there's full app reconcilers. Heroku and App Engine let you say things like, there ought to be a server running this code, which is like way nicer than there was before you could do that. And there's lots of other nice things about them as well. And then Kubernetes and friends ought to let you say, there ought to be a network of servers running this code. So I'm going to talk about Docker and Kubernetes specifically. I don't know how much hype you've heard. I'll give you a little bit of hype. And then some of the problems we've hit, because the marketing pages aren't real clear about the problems with the Docker and Kubernetes. Maybe you can help us. This is secretly a tech support meeting. Interesting. I'm glad to know that you think, some people think you know it. I don't know where I would say we were on our Docker Docker thing, I would say like maybe close to naively confident still, but we're headed, like we've got our toboggan out. We're going down. Going down there. So I would do the same imperative declarative thing for a software setup. How many of you work on computer programs, like are programmers in any capacity, like configure software? Okay. When you have for us at Pear Deck, when we went out to set out our developer machines, like giving you your machine on the first day means like remembering what software is installed, installing it the right order, wondering if we should say yes when it's like there's a new version available, and warning you about what not to change so that our various servers will like hook up on your dev machine and you'll be able to program. I like this icon. And then when you want to change the dev machine, it's like go to everyone's dev machine, upgrade node from 4 to 6, complications, and then you find out halfway through, like going all around, that Misha prefers Windows computers, and so none of this is going to work anyway. It's an old teacher thing. I saw you looking down, so I was like, call him out.
I'm fine. I prefer
But with Docker, I can say, like, clone the repo and run Docker, which is more fun. Because I've told Docker all the software that I think you ought to have, and now it reconciles your computer. So you have it all installed. Changing what you have installed means, like, can you pull the latest Git repo? And then it'll be installed. I need to agree or disagree with, like, how much better it is. But you can draw how you feel about this if you want. Somebody is, like, getting ready for... happiness. We'll see in aggregate how we feel about this. So again, upgrading dev is imperatively takes forever. You have to go around. Everyone hates you forever, and you end up deciding not to switch from Ruby SaaS to Node SaaS because you don't want to go to everyone's computer and install it. Hours spent. That's a lot of hours. So here's when somebody wants to upgrade Node in a Pear Deck development environment. They put in a pull request that changes a version of Node. Really importantly, you can do code review on this and collaborate on this before it happens. So just representing this declaratively helps us collaborate, because we have symbols to manipulate instead of like, what do you have installed in your computer, Connor? And then when developers pull this branch, they'll use this version of Node. And when they go back to their old branch that doesn't have this yet, they'll go back to the version of Node on that. And it's like, having it in source control helps you do everything. And the process for, and here's this benefits. I told myself I'd never be the guy that reads the slides to people, so there's lots of benefits. There are some gotchas, which I will talk about now. The Docker marketing site makes you feel like Docker is pure and will run the same time every time. I don't know if you guys got that feeling looking at Docker, but for me it was like, oh great, finally I'll have reproducible builds and like everything, like jargon. And it's a total lie. It runs different every time. And the other thing is like, it's like easy. All you have to do is make a pull request and change one number, and everything updates on all your devs machines as soon as they pull from Git. That also is not true. It doesn't work like It's supposed to be a joke. You're not laughing at all. You can get it to work like that, but on the marketing side, sort of makes you feel it's going to automatically work like that, and it's actually super complicated because the Docker file, the text thing, is not actually really the declaration. So you should call me out on this too. It's like Docker file is not really a declaration.
videos.
That's how many I owe you.
Yeah, I'm concentrating.
Yeah, you can move that on it. I think just every slide should have a big dot. You should run in like bubble mode. Then the other thing about Docker is you think they're going to be easy to understand, as easy as that text. And actually, when you start using images, you can you can get confused about how they run. I'm serious. We should have bubble mode. So I'm going to switch to talk about Kubernetes too. Kubernetes lets you do that same sort of productivity enhancement, but not on software configuration, on your whole app. So Kubernetes is for running apps on servers, and it has a declarative interface, which means you can say, like, my app should run on this server, and Kubernetes does the work of being the reconciler or the convergence machine and make that actually be true. Oh, I should switch it down. Oh, you can't see it at all. You should use Visual Studio Code. It's way better and everything. So this is super technical. You don't have to learn anything, but this is how you declare an app to Kubernetes. So instead of saying there ought to be 2 checkboxes, you say, for instance, there ought to be a service called Pear Deck Tech Talk WordPress, and it ought to have a load balancer that points to port 80. And here you can say, like, I want to run MariaDB also on a service. The important part here is, like, you can say, I want to run Docker, the WordPress version 4.7 thing. I want it to point to the MariaDB thing I just set up. I'm saying lots of complicated things. I hope I just mean to rattle off, like, these are the things normally you would have to do individually by hand at every server that you're trying to install WordPress on. Like, get a database set up and get a load balancer and terminate endpoints and stuff like that.
So you're setting up a WordPress cluster.
So I'm declaring that there ought to be a WordPress cluster, right? And it should look like this. And this should be the password, and the title should be demo blog, right? So I'm declaring lots of things about this, but in this file that I can check into Git. Okay. Then to make it actual reality, I run the reconciler, which is super hidden behind other windows. It's called kubectl. And you just say, like, okay, apply this config that. This is the name of the file that I just had. So all I'm saying is apply. And Kubernetes, oh, look, it's still connected. That's awesome. It's converging right now. It's making that all be true. So it's setting up, I'll show you a picture of it. It's setting up some different Docker containers. It takes a while. These have been running trying to start for a while. It's also requisitioning 3 different hard drives from my pool of hard drives that I have. So all these things need space to store the database and the blog files and run PHP and stuff, right? It's requisitioning those from my cloud provider and hooking them up to those pods. It's starting services, and this is still pending, but it's going to make an external IP address, because I said that it should. I didn't say that it should. I said there ought to be an external IP address. So that'll happen soon. And then I can understand it all. You can see there's lots of different things it can do, but I have 2 big deployments. One is the database, and one is the WordPress install itself. And so I can get a sense of, where's my like memory monitor? You're embarrassing me, dashboard. Well, normally it says like how much memory they're each using. Oh yeah, here we go. You can see they're starting to use memory and CPU. That normally works way better, I swear. There's like a graph of total CPU you have left and stuff. Anyway, so again, I just have this file and I can email you the file so that you could have this be true for you too. It makes this external IP address, and it's just like a freaking web page that is running WordPress that's connected to a database that's backed by 3 hard drives. It's load balanced with Google's load balancer stuff. And I can like, it's like works. I can log in. Yeah. It's like pretty tight. You get the idea. Like it's super actually works. I don't make one post. It's just like sync it in. Sync it in. Oh, that's not where you make new posts. Oh no. That's probably WordPress's fault. And this is like now an actual website. You can go to on your phone if you want. It's like real because I declared it ought to be so. Which gives you all kinds of power. It's pretty tight. And then like when I'm done, I can say like, I don't think it should be there anymore. There's no delete button here. That's lame. You can do things like delete the namespace. And now the website doesn't exist anymore. And all those hard drives are being returned and I'm not being charged. Can someone check, actually? So yeah, here's the deploying story where you're normally to do that, you would have to ask if anyone else is messing with your servers right now. Then you SSH in, change the code and environment variables. Heroku and App Engine are way better than this, but this is sort of the thought process behind that stuff. And with Kubernetes, deploying changes looks like this. Because I have declaration in Git, I change values and point to new code like this. And now this is the new thing I said that should be, and Kubernetes makes it be the new thing that is.
It's like the real Git keys, right?
Those are hashes. Not
commit
keys.
hashes.
Not keys.
Right.
But you're welcome to try.
Yeah, don't go to that URL. See the third computer with all the controls selected. I'm going to project it. Yeah. So honestly, being able to go through code review is the biggest benefit of that, I think. When you want to scale a service normally, imperatively, you have to get a new server and redeploy it and like make sure everything is hooked up and hook it up with your load balancers. But scaling on Kubernetes looks like this. You say, oh, I don't want 30, actually, there should be 80 of these workers, and then that will be true. You can code review this and talk about, do you really need 80 before it happens, and on some branches it'll be true, and on other branches of your repo it won't be true, and you can just, it's fine. Whereas if you're normally managing like a staging environment, you just wouldn't do this. Somebody would just decide and try on their own in the middle of the night when no one was watching. Server health imperatively is like check if the server is down, and if it is, restart it. And there's lots of solutions to do this automatically. But the important thing is here, even though it's automatic, it's still imperative. And when we switch it to declarative like this, which says, hey, there ought to be 2 servers running, it's alive if the path, like if you do a normal HTTP request to the root, and that returns something in less than a second, then the server is alive. Make sure that there's always 2 of them. In Kubernetes, if your server goes down and this stops being true, like the root GET request to the root URL stops returning 200, then Kubernetes will kill that one and start another one, so that there's two. It's like not only when you change a declaration is Kubernetes watching, but Kubernetes is always watching to make sure that there are always the amount of servers up that you thought. And then CI, I don't have examples because we don't actually do this that well yet, but using Docker Compose we do, you can declare that every branch in your Git repo should exist for real, and then run a real web browser against it as if it were the real thing. It's very important. And so every branch of your repo can actually have been tested in a really very close to production environment before you deploy it. Again, we actually do that with Docker still, and we're working on it. And just to wrap it up, like prototyping is really fast. You saw how fast it is to get WordPress installed. I didn't like install a database on my computer. My computer's clean. I didn't have to worry that it's going to conflict with my real work. So I don't have to be afraid of checking out your code or copying and pasting a curl to bash script from a website with invisible characters in the middle. The management tools you get just works with all your Git repo workflows. Humans are better at understanding files, right, than state they can't see at all. And then Kubernetes community is helpful, and there's tons of charts. Like actually that WordPress chart is just a word for declaration. That WordPress declaration that I showed you, totally plagiarized, got from the community. It's all set up. You guys want to see something really crazy? Oh, that's wrong. Like I showed you all that complicated work of doing all this stuff. The other thing you can do, there's a program called Helm, and you can be like, Helm install. And now that's also done. It's just the same thing. Helm install. There's a bunch of gotchas. Kubernetes is super cool, but we thought that it would be like Heroku, easy, and it's not. You can only deploy images of software. You can't deploy like your Ruby code. So there's like a whole bunch of setup you have to do before you can use it. It took us, I don't know, like a week probably to get everything set up so that we could use it. And then also Heroku and App Engine already integrate with databases and have monitoring and like a support team, and Kubernetes does not. You have to do everything yourself. Just a downer. And one other thing, Kubernetes seems super simple. Like look how simple it was to do WordPress. And I see actually that it doesn't seem super simple, but it's super complicated. I don't mean to make it sound simple.
Can you dig into that? Like, what's more complicated?
So, like, when you run a server and you want to run WordPress on it, there's something simple about, like, okay, so I'll get a server and I'll install WordPress on it, and then I'll run WordPress, and it'll, like, give me some errors, but I can see what the errors are on my command prompt and sort of fix them. In Kubernetes, there's no real machine, so getting, like, so there's nothing to like log into and mess around with. Like try installing WordPress. And diagnosing a problem means going into, you have to SSH into your into your Docker containers that are running inside virtual machines that are running inside actual machines. And so just like actually like copying a file from a Kubernetes container to your hard drive is hard. Little things like that would be easy if you were just like, install WordPress. So that level of abstraction lets you do this declarative Git stuff that is so great, and I think totally worth it. But you're like at a high level of abstraction, and if something is wrong, usually with your code, because Kubernetes is rock solid, but if something is wrong with your code, you're like pretty far away from your code, and you have to get through the abstraction to understand what's going on.
So, Minikube, is that the thing?
Yeah, so Kubernetes, the reconciler, you can run in lots of different environments. It's not tied to Google, although all these examples have been on Google. And Minikube is just a a way of pretending that you have a whole big cluster, but it's on your computer.
So does that help with, would it be easier to troubleshoot something? Like if something's broken on Google,
It's like the
likely
same.
to be broken locally?
So Minikube is your computer's running, and then Minikube starts a virtual machine on your computer. So you're simulating a computer, and then Kubernetes lives inside that computer and runs other containers inside that virtual computer. So you have actually the same level of indirection,
So it's not.
but your internet is slower. Is the main. Yeah.
So how would you compare it to? So I would describe this as automated infrastructure, right? How would you compare that to platform? Because that's another direction you could go. Instead of doing automated infrastructure, you could just buy into platform as a service.
Like App Engine? What's an example of a
the thing
platform?
I'm most familiar with is Azure, right? So in the .NET world, I can deploy a .NET app to an Azure app service. I don't have to worry about any machines. I don't have to worry about configuration. I just have to worry about deploying my app.
That sounds great as well.
Scale, connect to.
What Kubernetes is really good at, that's worked for us at Pear Deck, we have a service-oriented architecture. So it's not just one set of code. We have like a Java app and a JavaScript app and a Clojure app. It's embarrassing. This is a humble brag, embarrassing. Just use the latest functional languages, but it's kind of embarrassing. So Kubernetes also gives you abstractions to deal with that. Like it runs DNS between services so that if you have 5 of this service and 3 of that service, they can talk to each other just by like doing a GET request to a name like service A instead of needing to know pod names. I'm not very familiar at all with Microsoft's cloud stuff, so it could be that that's even better or different. I can't compare it very well. Should have just said that right at the beginning. I do think I've compared a lot of infrastructure for looking at stuff like this, and Kubernetes has an API where their abstractions match how I think about structuring applications. And other services seem to have abstractions more around the physical hardware and stuff, which I don't know anything about. So for me, Kubernetes was really natural to be like, I want these apps to be running, like let it be. Sorry. Yeah.
So how do you deal with stateful services like databases? Like you can create that WordPress thing, and then if I post on my blog a bunch of times, and I blow that thing away and bring it back up, all my blog posts are gone. So how do I?
So Kubernetes, one of the things it did is requisition durable storage, Kubernetes has a abstraction for you ought to have a hard drive that's 8 gigabytes, and when you reapply changes, like if I change the container or whatever, the hard drive actually doesn't get blown away. There's still the common advice is to not run a database in Kubernetes or in a container at all, I think is the common wisdom. So what we do is actually link out to third-party databases for production and only use the containerized ones in our staging environment. We don't even do that all the time. So we haven't, right, this talk is sort of about state. Kubernetes in some ways is stateless, right? Or the declarations are stateless. So if you care about your state, like your users probably care about their data, it can be dangerous because you accidentally delete everything if you declare that they don't have any data. And there's no I declare my users got their data back. So that's, I think, a big problem and question. But they're starting to roll out primitives like the persistent volume claims that sort of abstract hard drives, but also you get one hard drive that actually exists. I need to wrap up a little bit, I'm afraid. My ears are burning and we're almost out of time in the room. So we can keep talking afterwards. I just want to abstract the main lessons that we've learned that are transferable back to UI and I think other types of programming. Actually, I've applied it to my life, which is super nerdy, but true. When you switch to declarative styles, when it's possible, timing and order is less important, and time and order are the only thing that make your life hard. So get rid of them. Transitions between states can be automated. And just in general, if you have a transition between states, even if there's not a React for you or a Kubernetes for you, you can think about how to automate the transitions instead of how to program the transitions. And then you can get to declarative even in small ways inside one function. If you have an if statement or a loop, like, can you make it not be tiny by automating the transition between states? And then finally, declaring state instead of transitions is better for people. So, this is our final lesson. Talk is over. I'm going to bring Michael back up, but thanks very much for coming, and thanks for listening for so long.